Okay. First of all, I'm gonna introduce myself. My name's Abi Benecke. I'm actually a principal systems engineer with Exagrid Systems. Has anybody here heard of Exagrid? Okay. Let me start off with a pretty open-ended question real quick. Does anybody, who here still does tape for backups? Okay, keep your hands up. Who here still has a VCR? Okay, the reason behind this is if you really look at technology, it's come a long ways, right? The days of doing tape is kind of antiquated, and doing backups to tape are antiquated. Really, the only time that people really want to keep tape around now is why? Long-term retention, right? There's no way that I could keep years of data on primary storage or on some type of disk storage. It becomes too expensive of a proposition. Until deduplication, right? Deduplication really changed the whole backup story, right? Now I can take tons of data, dedupe it, compress it, store it into a smaller footprint. That's really what deduplication is all about. But how do I address explosive data growth? Well, in the past, how did people address it? With the tape library, what you did is you actually basically bought a model number, right? That model number had a finite amount of resources. It had so many slots for tape cartridges, so many slots for tape drives, and then as you added more tape drives and more cartridges, what happened to your backup jobs? They got longer and longer and longer, right? Because of that finite amount of resources. Finally, until you get to a point where your backups are no longer meeting the backup window, and then what do you have to do? You have to forklift upgrade. You have to go buy the next model number and start the process all over again, right? And unfortunately, well, or fortunately, back in the old days when you did do tape libraries and backups, this cycle or life cycle for a tape library was how long? Does anybody know? I'll tell you what Gartner says, and I'll tell you reality. Gartner says 5 to 7 years you keep a tape library, right? In reality, some of you guys that have tape libraries out there have had them for more than 10, right? You got duct tape and baling wire on them, and you're going to keep them as long as you can until they finally fail, and then you have to go to the next bigger tape library. Well, unfortunately, with deduplication, what they did was they introduced some type of storage, right? They said, hey, let's take this great idea of dedupe, let's put it on a legacy storage format with a scale-up architecture, right, where I have a head unit, and then I put disk trays in it, and I basically mimic a tape library. Why? Because my finite amount of resources is that head unit, right? And as I add more trays of disks, what happens to my backup? They get longer and longer and longer again until it finally breaks, and then what do you have to do? Forklift upgrade and go buy the next model number. Here's what they haven't done, or what people don't realize. They've taken that 5 to 7 year life cycle, and then now they've done it to 18 to 36 months on disk. Can anybody tell me why? Who comes out with a processor every 18 months? Intel. Who comes out with a storage head unit every 18.2 months? Anybody that does inline deduplication. And that's what we'll talk about today, is the differences between us and everybody else. So as a company, Exagrid, we've been around 13 years. We've been shipping product for 11 years. When we talk about that endless cycle of grow, break, and replace, I will tell you that we've not end-of-life to product in the 11 years of shipping product. Tell me somebody that can say that. Not too many companies out there. So we've not end-of-life to product in the 11 years of our existence. All we have is a storage platform that has deduplication and compression and replication built into it. All we are is a target. That's all we do. We don't do anything else. We don't do primary disks. We don't do secondary disks, tertiary disks. All we are is a target for backup. Because of this, we do it really well. Right? We've taken a technology like high performance computing and scale up architecture with a grid approach, and we brought that to the backup space. Why not? What are backups? Backups are a whole bunch of sequential jobs that you line up back to back and you dump it to some type of device. If you're dumping it to a single end controller, what's the bottleneck? The controller. If I have multiple nodes in a grid, now I can spread that data across as many nodes as possible, increasing my performance. Does it make sense? Isilon, Compellent, all those guys of the world that did it on the primary disk side, we're doing it on the backup side, right? And because it's capacity driven, we don't have to end-of-life products every time a new Intel processor comes out. All we have to do is guarantee a throughput per node. If I can tell you as a customer, that I can guarantee a 4 to 6 hour backup window, would you want to continue talking with me? You would, right? Because what's the biggest problem in backups right now? Single biggest problem in backup is the time it takes to do a backup. What's the second biggest problem? Time it takes to do a restore, right? So how do I address that, right? The other thing that, and this is just recently because of the whole advent of virtual machines, is how do I back up a virtual machine effectively without treating it like a physical machine? And then how do I take advantage of the advanced recovery techniques that other vendors use, like Veeam, where I can do instant VM recovery, instant VM restore, instant everything, right? How do I take advantage of that with a deduplication backup platform? And we'll talk more about that and how we do that. So when you look at deduplication, there's really two ways to do it. There's inline, and then there's us, right? When you're looking at inline deduplication, there's two problems with inline. You could either do it hardware-based or you could do it software-based. Each one has its own implication and the costs associated with that. So you got to pay a dedupe tax somewhere, right? If you're looking at software-based deduplication at the client level, right, which means I'm going to put an agent on every client out there. I'm going to let that guy do deduplication at that client, like steal CPU cycles from it, from my Exchange server, my database servers, my file servers, my VMware servers. I'm going to steal a portion of that CPU cycle just to be able to do deduplication. And if I'm going to do it at a very large block size, because software can't do it at a byte level, they have to do it at a block level. Typically it's 128K blocks, and it's fixed content. So that means that block has to match exactly for me to be able to get deduplication out of it, right? If I'm doing it at that level and only with a portion of my CPU cycles, my deduplication rates are going to suffer dramatically, right? With application or agent-based deduplication, we typically only see, 2 to 4 to 1 dedupe rates. And again, it makes sense why. Large block sizes, only a portion of the CPU are used to be able to do that dedupe. If they move that to a media server, which most backup applications say, yes, we do dedupe now, just turn it on at the media server. Now I'm dedicating a server to be able to do that deduplication, but now I have to add storage to it. Even with dedicated resources with software-based dedupe, the best dedupe rates you'll ever see out there is somewhere between 4 to 7 to 1 dedupe rates, right? If you're going to look at deduplication, look at a purpose-built appliance. Why? Because we do it at the byte level, not at the block level, right? And we're going to get very granular level backups. And now I'm going to get 20 to 30 to 1 dedupe rates versus 7 to 1 dedupe rates. Now, if I were to do 7 to 1 dedupe rates at a media server, how much more storage would I have to buy to be able to match what an Exagrid, Quantum, Data Domain, anybody else would do? 5x the storage, 6x the storage, depending on who the vendor is, right? And so it just makes sense. Use a purpose-built appliance to be able to do deduplication. If you're looking at purpose-built appliances, I'm going to name the 4 horsemen. Right? These are all Gen 1 dedupe appliances out there that they all do it the same. Quantum, Data Domain, Dell, HP Store Ones. All these guys do inline dedupe, which means I have to manipulate the data while it's in flight to be able to do that deduplication. I look at a block size, I do a hash compare of the block, I say, yes, I've seen the data, no, I've not seen the data. I update my hash table, I compress my data, and then I finally put it on disk. Very intense process, very processor driven. That's why 66% of the cost of an inline solution is in what? The head unit. It's the processing power needed to be able to do that inline dedupe. Guess what? Processing power is expensive, right? Here's the problem with inline dedupe also, is that you'll never get a full backup, or the only time you get a full backup on an inline solution is when? The very first backup. That's where you make a compressed copy of it, and it's the oldest data on the box. Every backup after that is just a delta change that sits on top of that reference point. So if I had to do a restore, what do I have to do? Go grab the oldest data on the box, which is the reference point, and then pin all the delta changes back together again. That's the problem with inline deduplication. It's not about the backup anymore. It's about the restore. And if I have products like Veeam that has instant VM recovery, instant VM restore, or anything like that, do I get that with this? No, I don't. I negate the powers of Veeam by putting it on an inline box because of the whole idea of doing rehydration. So how do we fix that? We basically said, look, let's take deduplication out of the backup window, land it to straight disk, do disk-to-disk backup, and as soon as it lands there, the backup job's finished, right? So now we've increased the backup time, but more importantly, we've increased the restore time. Why? 92% of the time when you do a restore, where do you do it from? your last full backup. So if we have that last full backup in the landing zone, undeduped and uncompressed in native format, now I can satisfy 92% of my restore requests. Now I can take advantage of advanced recovery techniques from Veeam like instant VM recovery, instant VM restore, all that stuff right out of the landing zone. No rehydration, so there is no tax that needs to be paid to be able to do that. Then what we'll do is we'll take that data, dedupe it, compress it, and store it into a repository, which is the second part of our architecture. So again, the first part is basically just very fast disk. Think of it as high-speed cache for backup and for restore. The second part is the repository, which gives us 16 weeks of retention at no additional cost. 16 weeks at no additional cost. If I were to have a straight disk, like Veeam going to straight disk, and I had wanted to do 16 weeks worth of retention, how much more disk would I have to buy now? If I'm only going to get 4, 5, 6, 7 to 1 dedupe rates. Think about that. Okay. When it comes to the landing zone, really it allows me to, again, take advantage of those advanced recovery techniques like instant VM recovery, instant VM restores. Everybody else would have to go through that rehydration process to be able to provide a restore point to then take advantage of that. The only way to do what we do in front of a Quantum, Data Domain, Dell, or anybody else is to put some other storage. You do disk-to-disk backup to that storage, and then you archive it to a Data Domain, Quantum, or anybody else. Why would I want to do that? Why would I just not buy a product that gives me all of it in one? When it comes to support in a heterogeneous environment, we support all the major backup applications that are out there. There's two that we don't. We don't support Avamar, and we don't support Aperture, only because they're very proprietary. They have their own infrastructures that they built around that. And of course, they want you to buy data domain storage, and they want you to use Networker. And they, it's one of those things where they just they want to keep you in a can. With us, one of the things that we did apart from everybody else is that when you become an Exagrid customer, we actually assign you a tier 3 type support engineer that knows the backup application that you have. So you get a tier 3 guy, a named account guy that says, yes, hey, I know Veeam very well. I'll help you through the installation. I'll help you with the integration, and then moving forward, I'll support your infrastructure. So he knows your infrastructure intimately. This is something that a lot of vendors don't do. Right, this really eliminates finger pointing when it comes to, is it the backup app? Is it the hardware? Is it the network? Is it the tape drive? And everybody's pointing their fingers. Well, we do it all. It's all part of our maintenance plan. When it comes to Veeam, and you're going to probably wonder why I've said Veeam 6 times already, we took something a little bit further with Veeam. We have a great relationship with Veeam because we already know that Veeam has 80% of the market share when it comes to virtual machines, right? They've cracked the code on the virtual machine to know how to back it up with agentless. By backing it up at a VMDK, do change block tracking at the actual virtual machine for the unique data of each virtual machine. And then what I can do is that if I had to pull something, I could crack the VMDK, pull a file out, pull a user out, do everything at this VMDK level. Well, why not take that VMDK, put it in our landing zone, and then have it instantly available there for all those advanced recovery techniques? Let's take it one step further. Why not open up our kernel to Veeam to when we do a Veeam to Veeam connection, instead of talking at CIFS or NFS, which is a very heavyweight protocol, why not talk at the transport layer? What does that do for us? What does it do for Veeam? Now it allows all that instant VM recovery and everything to be actually enhanced. So all the qualities of Veeam, instead of being negated by inline deduplication, it's actually accelerated by the landing zone. Does that make sense? Again, we're the only vendor that has this type of integration with Veeam. Veeam 9 did come out and have some extra support for a lot of the dedupe appliances out there, but it doesn't have this type of integration. What it also does, it allows us to do something called synthetic fulls at the actual Exagrid itself. So on a synthetic full, typically what would happen on a synthetic full, the actual synthetic full would be done on the media server. So what does that mean? I do a nightly incremental, and at the end of the week, I reclimate, I put it all back together, and I fake a full, right? That's all done at the media server. The media server has to go out there, pull the data, pull the clients, pull all that data out, and then write it back out again. Well, if I can put that synthetic full on the Exagrid itself and make us look like a proxy server within the Veeam architecture, now that whole synthetic full process is actually done on the Exagrid itself, not at the media server. So it's less bandwidth intensive, it's less CPU intensive. All of it's done right where the data resides. And there is no reclamation. Why? Because the data's in the landing zone, undeduped and uncompressed in native format, right? So this does make a really big difference when we're doing synthetic fulls. Okay, how many minutes do I have? 9 minutes, okay. So let's do an example of what, how we actually do a backup. Now, when we size our customers, we actually size them for what a full backup is. Why do we do that? We want to keep that full backup in the landing zone undeduped and uncompressed. I will tell you that our competition says, well, Exagrid needs double the disk space. And they're 100% correct. 66% of our cost is in storage capacity. 66% of the cost of our competition is in processing power. Which do you think is more expensive? Okay. Processing power. Because we're capacity driven, when a bigger hard drive comes out and we come out with a bigger model number, as long as we still guarantee that 4 to 6 hour bandwidth on that one box, do I have to end of life a product? No, I don't. So we have a 1 terabyte box, which is our very first box that we still sell today. We have a 40 terabyte box now that allows us to scale up to 1 petabyte in a single grid. That's 25 nodes in a single grid, scaling all the way up to 1 petabyte. So I can go from 1 terabyte to 1 petabyte and still guarantee a 4 to 6 hour backup window. 200 terabytes an hour of throughput. So if you're looking at the way we size it around a landing zone, right? In this example, I had a customer that wanted to do a TCO on a 10 terabyte backup. They were doing it to tape and they said, show us why it would be cheaper to go to an Exagrid. So we sized them for an EX10000. The 10000 is a 10 terabyte box, again, 10 terabytes of landing zone, and also 10 terabytes of repository, but it allows me to do that 10 terabyte backup in a 4 to 6 hour backup window. Once it lands in the landing zone, I immediately close the backup job, and now it's immediately available for restores. Right, instant VM recovery, instant VM restore, all that comes right out of the landing zone. Then what I'll do is just like a 4 horsemen, you know, EMC, data domain, quantum, all those other guys, I'm going to create a reference point. But that reference point is going to always be a compressed copy of the last full backup. So that's the second copy of my data. Now I'm going to wait for the next backup to happen. It'll actually update the landing zone, update the reference point, and then store the delta changes between them. So if you really look at this, this is actually a reverse incremental. Instead of having my oldest data be on the bottom, I'm flipping it around, and on my newest data is always, that reference point is always going to be a latest copy of my reference point. That makes recoveries of even dated information that much faster. I don't have to rehydrate all that data in turn. I just go to the reference point, say, hey, give me week number 3, and like unikernels, I just go down to that plugin and say, or that one process, and say, hey, I'm going to go ahead and just restore that process instead of doing it all sequentially. If I'm going to do 20 to 1 dedupe rates on a 10 terabyte backup, that's only going to be 200 gigabytes in size, the delta changes, right? So that's really all I'm storing on subsequent backups. I'll do 9 of these. So on 9 full backups of 10 terabytes, if I was doing that to tape, how many terabytes of tape would I have consumed? Easy math, 9 times 10, 90 terabytes, right? Most everybody does grandfather, father, son rotations. So that's 90 times 3. That's 270 terabytes of tape. Does everybody agree? Okay, now, if I'm sending that to Iron Mountain or offsiting that data, that's 270 terabytes times 2. That's 540 terabytes of tape for a 10 terabyte backup for 9 weeks. Tell me tape is cheap. Tell me the man hours of labeling the tapes, rotating the tapes, taking the tapes off site is cheap. What we've done is we've taken 90 terabytes of data, we've deduped it, compressed it, and stored it into a 6.6 terabyte footprint. That's what dedupe is all about, right? It's taking 10 pounds of stuff and putting it into a 2-pound bag, right? And that's what we've done very well. If we're going to do replication, all I would need is 6.6 terabytes of data at a secondary site or storage to be able to replicate that data from my primary to my secondary site. I don't have to have 2x, 3x, whatever the disk space, right? Our competition, if you bought model XYZ at the primary site, you would have to buy model XYZ at the secondary site. All we would have to use is 6.6 terabytes of data for a 90 terabyte full backup. So we can actually take an EX4000, which is an 8 terabyte box, 4 landing zone, 4 repository, make it all repository, and then now house that 6.6 terabytes of data. Does that make sense? Any questions?
Does your replication have to be Exagrid product, or can it be?
Because replication is built into it, yes, we like it to be another Exagrid. If you're going to use Veeam, I can actually say use a backup copy job, and I don't care what the target is. I could just backup copy job it to another target. Another reason why we like Veeam. But you would use Veeam's replication instead of our replication. Our replication is just at the byte level. So whatever the delta change is that happens between the backups, that's the only thing that gets replicated across the wire. Does that make sense? So we're a lot more efficient when it comes to, actually when I say efficient, you don't need as big a pipe to do replication with us, because it's just at the delta change. Last part of it, guys. So when it comes to the last part of our value prop is really the scalability aspect of it. If you look at everybody else on the left-hand side, they all have a scale-up architecture. You buy a head unit, and that's your limited amount of throughput, right? And I won't pick on one of our competitors, but yes, I will. They have a product that does 9.1 terabytes an hour, right? That's what their head unit does. They use 36 terabyte trays. One tray, how long does it take to do a backup? 4 hours, easy math, right? What happens when I add another tray? 8 hours. What happens when I add another tray? 12 hours. Another tray, 16 hours. So as I grow to the capacity of that box, my backups get longer and longer and longer again, until finally they don't happen in time, and then I have to forklift upgrade the head unit and start the process all over again. With us, you buy what you need, you pay as you grow, right? You buy a head unit, it's got processing power, memory, and throughput, right? And as your storage capacity needs grow, you add another node. And that node expands that landing zone that I'm talking about across all the nodes in the grid. So if I had 25 nodes in the grid, and they were 40 terabyte nodes, I would have a landing zone that was 1 petabyte, where now I could direct my backups to it. Right? This is really the magic of the Exagrid, is spreading that data across as many nodes as possible, getting concurrency, because when we look at backup jobs, it's all about the concurrency, right? How many jobs can I have going down a single path at one time? If I can have 15 simultaneous jobs going across 1 gigabit Ethernet port, and I've got 5 ports, that's 75 concurrent jobs per node. Multiply that times 20 or 25. That's a whole hell of a lot of backup jobs going to one single grid. And that's really what we designed this for, is around high performance computing. If you look at it, the 4000 can do 8 terabytes an hour. 2 of them 16 terabytes, 4 of them 32 terabytes, 25 of them 200 terabytes an hour. Right? This is a really good story for us. So even as you grow to the capacity of a grid, guess what? You still stay within a 4 to 6 hour backup window. And this is how we do it. All right, good. Last part of it is just about the redundancy built into it. We do RAID 6. I know people like to get wrapped around the axle on that and IOs per second. Who cares what the IOs per second are? Nobody. If I can guarantee a 4 to 6 hour backup window, you don't really need to worry about IOs per second. You don't need to worry about whether it's flash disk or SAS disk or SATA disk or whatever. We guarantee that throughput. We actually put it in writing. If we can't do a 4 to 6 hour backup window, we'll actually add equipment to make sure we get that 4 to 6 hour backup window. So everything's redundant in it. Part of maintenance, one of the things that we did a little bit different is that when you buy maintenance, guess what? You get deduplication, compression, replication, installation, integration with your backup application. You get phone home capabilities where the guy that's your named support engineer gets emails anytime one of these devices actually has a failure or a warning signal. We guarantee 24-hour part replacement. So if you have a drive that has random read-write errors, we will actually initiate an RMA return, send the drive to you, you replace it, and it'll get there within 24 hours. So again, if you go to our website, we have 350 customer success stories. Over half of those talk about our customer support guys that basically integrate with the backup application and take care of your customers. If you have backup exec, net backup, some of those other traditional backup applications, nobody calls those guys anymore. Why? When you call them, first of all, it's outsourced somewhere. You get a tier 1 guy that asks you 10 questions like, did you reboot the box? What version of software do you have? What version of firmware do you have? You go through that whole process, and then they pass you on to a tier 2 guy, which asks you the same 10 questions. Then he redirects you to a guy that can actually start troubleshooting. Well, we eliminated all that by giving you an assigned person, and he'll know your backup application, help you troubleshoot it right off the bat. Yes, sir. All right. Any questions? That's our value proposition. Landing zone, scalability, all at a fraction of the cost, and world-class support. I'll be out at the table if you guys have any questions. Please come by and talk to us. Thank you.